one goes to the default, so chose you.
All right.
Goes to that screen, and just go back and forth.
I don't know if I really.
Say something.
Testing, testing.
Go for it.
Oh wait, is the volume all low? Oh, there you go. Okay, so I am talking.
Yeah.
All
I
right.
can hear you. Perfect.
Cool. Is there a chat? Are you monitoring that, or how does that work?
There is a chat. That's a good question.
Well, I didn't know that was even a feature.
There you have it.
Huh. All right. Cool. All right. So, just gonna go back to. How did I go back to slides? Press 2.
Yeah.
Cool. All right. Cool. And there's no me in the corner or anything?
No.
All right. So welcome to natHACKS Git/GitHub workshop. It will be mostly Git. Will be a little bit of GitHub, but it's for the most part going to be Git focused. Oh, that's not the screen I wanted. Oh, this is the screen I want. There we go. So first, a little bit about myself. My name's Gino. I'm the director of web. I'm currently doing a Bachelor of Science Computing Science at the University of Alberta with a focus on computer architecture and compilers. Enough about me. All right, prerequisites for this workshop. So if you are on Windows, go to git-csm.com to download Git from there. If you are on Mac OS, there's an Xcode command. If you're on a Debian Ubuntu machine, you can do sudo apt install git. That one will also work if you're on WSL on the Ubuntu version. And then if you're on Arch or Manjaro, a sudo pacman-s git will also work. Another prerequisite you'll have to make is a GitHub account. So you just head over to github.com, hit sign up, and it should be, I don't know, like 3 minutes for your sign up. I'm going to assume those things are done, and I'm just going to move ahead. All right, typical content. So what we're going to cover is, first of all, what is a version control system? Then we're going to go into how Git does version control system. Next, we're going to go into creating a repository. And finally, we're going to go over a couple of Git commands. So what is a version control software or system? So first of all, why use version control? So if you worked on other projects without version control, you might have had to make a bunch of copies for a file for different versions, and your version control was essentially just renaming a copy of the file to a specific version, right? But that's not very scalable, right? Pretty quickly, whatever you thought was your final edition wasn't quite final because you had to do some other quick last-minute change. And if you're doing this for just one file, it'll quickly spiral out of control when you're working with a large code base that has hundreds of files. All right, so how does Git handle versions, all right? So I kind of told you the problem, but what's the solution, right? So version control, what it does, essentially, it's a system that it has in place in order to control your versions, which is kind of just repeating the definition a different way. But in practical terms, it essentially means that you don't have to have multiple files, right? As far as you're concerned, there is one file, and then if you access the version control, then you can see that history of the file across multiple different versions, and you can even see who made what changes. All right, so how does Git handle versions? So the way Git does it, it's essentially, you can think of it as one large linked list until you get into branches, and it's more of a tree. But the way you can kind of think about it is essentially as one big linear list. Again, until we start discussing about branches. And so usually, again, there's a lot of things, like if you know the advanced concepts, I'm just kind of going to simplify some things. So I'm not going to talk about like a detached state or anything like that. But in simple terms, you're going to be pointing at a head, which is basically where you're currently at, right? And then you have your previous versions before you. So your current head will point at a previous version, wherever like it basically spawned out of, whatever it changed. And that version, that snapshot in time, will point to a previous snapshot in time, and so on. And these will usually be also accompanied by a message to kind of give you a little shorthand of what that version is, what it changed. And then also ideally, you also have like the list of actual changes for that version. Oh, there's a chat. If there's any questions so far, go ahead and ask. Otherwise, kind of skip the theory a little bit and just go straight into the fun stuff. And I don't know how to exit from OBS. There we go. All right, so creating a repository. These speaker notes are totally not accurate, but whatever. So if I go into this one, actually, not that one. If I want to create a GitHub repository, I'll go here at the top, right, create new, and I would click new repository. There's a way to do this in command line, but as a beginner, it'll actually be a little bit more complicated because then you'll have to hook it up, even though the commands are there. I find it easier to just do it through the website, and then all you have to do afterwards is just clone it. So I'm going to make a quick repository to make this under NeurAlberta. I'll call it Git Workshop 23. Oh. Now I don't know where OBS is showing. Yeah, it's still showing that. Cool. All right. So I got my Git Workshop 23. I can give it a description if I want. I can make it public or private. I'm going to make it public so you can reference this afterwards. And then it's got a couple other options in terms of like what files I want to add off the get-go. I'm going to leave all these blank, and I'm just going to create an empty repository. So I'll click at the bottom, and boom, I get this. A bunch of commands of stuff I could do, but that's only showing me right now because there's nothing in this repository. It's completely empty. So now I want to take this repository and kind of clone it. And so that kind of goes into the next table, which is how to use Git. Oh, there we go. It's how to use Git, right? So if you ever do like man git, it'll pretty much give you all the information you need to do, or git and then the command and then -- help will usually give you the second information page. But the main ones we're going to cover today are git clone, git add, git commit, git pull, git push, git checkout, which is slightly out of date. I believe the new preferred way is to do a git switch, but it's not a problem. Oh yeah, in the end, there will be a link to some resources you can use. All right, let's get into the code. So first, I'm going to clone this. So what I'm going to do is I'm going to go into here. There's HTTPS or SSH. For now, you'll probably, if you haven't done this before, you'll probably have to use the HTTPS version. And you'll also have to set up a private access token, which you can quickly go into your own settings. So if you went to your settings, right here, then you went to password and authentication, then you can create some passkeys. I believe those are, oh no, it's passkey slightly different. Let's see, application. I have not set up personal access tokens in a long time. All right, so that one might require a bit of looking into, but the one I would always do pretty much right after this workshop, and maybe we have time at the end, is to set up SSH keys, which will be much easier. That's what I will be personally using for this workshop. So I go back into my SSH, I'll copy it. Whether you HTTPS or SSH, the following command will be the same though. We'll go back into the terminal now. We'll pretty much spend the rest of the workshop in the terminal. Whoop, there we go. Make that a little bit bigger. All right, nope, there we go. So I'm gonna just type git clone, and then I'm gonna paste in the URL. So I'm gonna hit enter, and it's gonna clone it, right? And now if I do a quick ls of my terminal, I see that there is now a new folder called Git Workshop, and I can even cd into that. Right? If I do another quick ls, it looks empty. But if I add the a flag to show my hidden files, I actually see there's a .git folder. So that is essentially where all the Git lives. That's where the actual version control lives. As a beginner, you don't ever want to modify this file. But once you kind of go more advanced, you might end up modifying this file. Ideally, still, you won't edit it directly unless you really know what you're doing. But you usually will just do some commands. For example, if I cat my .git config, actually I don't want the beginning. It'll show you some stuff here, and I can even type a command, for example, that will modify it, and this is something you probably will have to type yourself, which is git config user.name, if you haven't set up Git before. And boom. So normally you'll want to add a -- global if it's your first time setting it up, because you want to tell Git who you are, so what your name is and what your email is, so user.name and user.email. I'm not going to do it here because I believe there's a global one set and I don't want to mess with it. So I'm going to make this one that will only modify this specific repository. So if I go back and I cat out the other thing, you can see there's a new line, user and then name and then my name. So you'll probably want to have a -- global at the end of yours. Then I'm going to go ahead and set my email. Boom. All right, set up. So if you don't do this, later on when you do try to do your Git commit, Git will yell at you and tell you that it doesn't know who you are. So if you get that error, you just have to set up your username and user email. All right, so we've cloned a repository. We have a repository. There's nothing there. So what should we do next? Well, assuming we're going to make some code, we should probably just start writing some code, right? So I'm going to create an empty file. I'll just call it main.py, right? It exists, but there's not much in there, right? If I do an ls, it exists. If I do a cat, boom, it's there, right? But just because I've created it, Git doesn't automatically add it into its version control, right? So we have to manually tell it, hey, I want this to be tracked, and I want this as, I want to take a snapshot of this file at this time, right? So you don't directly commit things. You'll want to stage them first, right? And the advantage there is by having kind of this middle step is that if you accidentally stage something that you didn't want to have staged, it'll be very easy to unstage it or even revert it than it will be after you've committed and after you've pushed it. It's still possible to get rid of it even after you've committed it, and it's even possible to get rid of that commit after you've pushed it, but it becomes much harder and it kind of requires more advanced commands to kind of fix those errors. So once it's in stage, it's a lot easier to modify, right? And I can quickly check what's in stage just by running a git status, right? And so it'll tell me, right, I'm on branch main, there's no commits yet. I have one untracked file, which is main.py, right? So that means that it knows it's there, but it's not tracking at the moment. So by default, most files you will want to track, but there are a number of files you won't want to track. And when those files follow a certain pattern, you'll learn later on there's a special file where you can kind of give it a list of these patterns, and then it'll automatically know never to track those specific sorts of files. So anything like environment files, anything that's kind of cached, so anything that's kind of being generated as a side effect of your program. So like Python would be your Python cache. If you're working in C or C++, it would be your object files, anything like that. That's always going to be rebuilt anyways. You wouldn't necessarily want to get tracking it. So those are things you might want to ignore. In this case, my main.py, I do want to keep track of that, right? So all I'm going to do is git add. And then you have a couple of options here, right? You can either do dot, which will be the current directory and everything down recursively. I can just spell out the actual file I want. I can use a bash glob, for example. And if I just want everything regardless of what level I'm at, because I may be lower into the Git repository, but I want to add everything, even the stuff that's above me, I can just do A-A. Boom, I run that, I run git status again. And now I see, okay, these changes are to be committed. So now they're staged, and Git is tracking what this is, but it still hasn't committed it. So there's still no snapshot that, hey, I just created this file. So if I want to create that snapshot, I can just write git commit. -m is kind of shorthand for a message. If you don't do this and you just press enter, just git commit by itself, it'll open either Nano or Vim or whatever you have set up as your text editor, and it'll ask you to create your git message like that. I find it quick and easier, just have it all in one command. So in quotation marks, I'm going to write my message. So created empty Python file, for example. And boom. So another note, as you kind of become more advanced and more proficient is this, you want to have descriptive git commit messages, but you also want them to be short and concise, right? So you don't want something that's like 100 characters long that takes a while to read, but you also don't want just something that says, oh, added some random file, right? Especially if you're just modifying something in a file, you probably want to be, hey, I'm fixing this specific bug, or you know, change the button colors to blue, for example, if I was working on a website. So create my git commit, it's all there. But if I am to go back to GitHub right here, and I hit refresh, I still don't see my changes yet. Well, that's because those changes are now locally made, but now I need to sync the origin server, right? I need to tell GitHub, hey, I have these changes, please sync them, right? So the command you'll want to do is you'll want to do a git push. And this will push whatever commits you have onto the server. Vice versa, you'll probably want to do git pulls quite often. So the server might have changes that you don't have locally, and so you'll want to do a git pull, right? So if I do a git pull, it'll tell me there's nothing, but I'm already up to date, which is great. If I wanted to just check whether there are changes, but not necessarily download them, because I don't know, maybe I'm on a fixed bandwidth or something, you'll do a git fetch, right? Which will just kind of take that in the background, but won't actually download or apply those latest changes. So, then my git pull, git fetch. So a lot of times if you have a conflict, let's say I worked on something, but my friend Cameron might have also pushed something first, and then I try to push, it'll give me an error, and then it'll tell me to pull first. So then I'll have to pull, and if there's any conflicts, I'll have to fix the conflicts, and then afterwards I can push. All right. So that's pretty simple, right? So now I can make another change, right, to my file. Cool. So I can go here and I can type in, let's say, just print natHACKS. Oh. natHACKS 23. All right. So if I were to run that too, boom, natHACKS 23. Cool, I made this change in my code. Well, I want to commit this again, right? Now I could do a git add again, right? Git add. Sorry, I'm used to having a lot of aliases on mine. So I can do a git add, you know, again, run that. But if Git is already tracking that specific file, then a quick shorthand is you can actually then just do a git commit, give it the A flag, and that'll essentially tell it, hey, add anything that you're already tracking, and then my message, right? So print natHACKS banner, for example, right? And I could hit enter here, right? And to kind of show you what it won't track, let's say if I create a new file, and I'll just call it log.py. Right now I have two files, log.py, main.py, and I were to run that other command again. So git commit -a -m. I do print natHACKS banner. You'll see it only one file changed and there's only one insertion, right? It doesn't show the second file. If I do a git status, oh, If I do git status, it still says that there's an untracked file, right? And so just because you do a -a, it doesn't mean it'll add everything that you've made changes to. It's only going to add those changes if Git is tracking them. So in this example, the log.py wasn't being tracked, right? And now let's say that we have, actually no, I'll do that later. All right, so those are the changes. Let's say, actually I do want to add my log.py just in case. So git add log.py, git commit. So I'll do create logger file. And then I'll do another. So now I have two, if I check here, I have these two commits now in my history, right? I just did git log. Go back into the server at GitHub. I still see the one change. Why? It's because I haven't synced those changes, right? So I have to tell Git again that I want to push my changes. So now it's pushed them. If I go back into Git, boom, it's right there. Now they appear. Matter of fact, even going to the commit history, and I can see all my commit messages right there. All right. So let's go into branches. All right, so branches, you can kind of think of those as branches in timelines, right? So at a certain point in time, I don't know if you've seen Marvel or not, right? Especially they're all into the whole multiple timelines and all that stuff. But basically, you can think of branches as different timelines, alternate timelines. The way they're useful is that if you want to work on a certain feature that may break stuff for other people, you can kind of work that on a separate timeline, right? That doesn't affect other people. And then once you're done, you can merge that back into the main timeline, right? So if you kind of think of them in timelines, the analogy for the most part holds up. So I want to do that, right? I want to create on this new groundbreaking feature, but it's probably, if I keep doing it on the main branch, it's gonna screw up things for everybody else. And that's another practice you'll learn later down the line. You'll rarely want to work directly on your main branch. You always want to make some alternate branch to work on. But yeah, let's say for this hackathon, we're really strapped for time. A lot of people are pushing straight to main, but I know I'm making these breaking changes, so I don't want to break the workflow for other people while they're working on it. So I'm going to do it in a separate branch. So what you do is you do git switch, give it -c for create. So I want to switch to a branch, but this branch doesn't exist, so I need to create it. So I give it -c, and I can name my branch, let's say, I don't know. Again, the branches, you also want to be somewhat descriptive with how you name them. But in this case, I'm just going to call it demo because I have no creativity. So git switch demo. Now I'm on this new branch demo. If I do a git status, it says on branch demo. If I do a git branch as well, it'll even show me, again, I'm on the demo branch. So now I can do whatever changes I want here. So let's say I want to create another file, which is called demo.py, right? I can then add it, I can commit it, create demo file, and I can even push it. So now I'm going to do this push, and it's going to give me an error. Luckily enough, when it gives me the error, it's also going to tell me how I can fix it. What's going to happen here is that I'm pushing this branch to GitHub's equivalent demo branch. But the problem is that GitHub's version of Git doesn't have this branch. This branch doesn't exist. So I'm going to have to tell it, hey, actually, you're going to create this branch, and you're going to create it based on this one. And lucky enough, it tells exactly what to type in this case. So I have to do git set upstream origin. Ooh. All right, so what the command is actually doing. So I'm going to obviously tell it to push, but there's no upstream. There's nothing upstream, so I'm going to tell it to set up the upstream on origin. In this case, origin is, for the most part, just means the repo that you cloned. Again, once you go more advanced, you can have other upstreams and different things, but for the sake of simplicity, origin. And then demo, it's a good habit. I would just keep it as the same branch name. You can technically have this as a different branch name on GitHub, but it can become confusing later on, so I suggest just keep it the same. So I hit enter. Now it's going to push it. It's going to create that branch for me upstream. If I go back, I can even see that there's this new branch called, if I refresh, I hit here, there's this new branch called demo. And this demo one has this demo.py. But if I go back to the main, demo.py doesn't exist, right? Now, later on, I could do a command that does the merge, so I can merge it back into the main. However, unless you're doing that with your own branches for some advanced use case, I also suggest not doing it. I would suggest just going on GitHub itself and using their pull request feature. Reason being is that with the pull request feature, you're essentially requesting to merge it, and then other people can give their input on the changes you've made, right? People can review it, and they can give you feedback. And in a competition like natHACKS, that will become pretty handy. So I want to compare changes, so I want to compare my demo onto main. I'm going to click create pull request, and in here I can give it a title. So my first pull request, right? And then it's got some nice features. For example, I can ask for reviewers, so I can select Cameron, for example, as one of the reviewers who can review it, right? And there's other things, there's projects, there's all sorts of stuff. But for the most part, I should give it a title, I give it some description. Try to be as descriptive as you can in terms of what is this doing. In this case, it's really not doing much. And I create my pull request. Boom. Now, again, more advanced features, you can have CI pipelines and everything run on these pull requests, so you can check for unit tests, things like that. But in this case, we don't have anything like that. And now I could wait for a review from Cameron. Maybe he approves it, maybe he denies it, whatever. In this case, for the sake of the demo, I'm just going to assume he approved it, but it would tell you. And then all you got to do here is then afterwards click, you merge pull requests. You do have some options. You can do squash and merge. You can do rebase and merge. I can explain what they are at the end of the workshop, but for the workshop itself, for natHACKS itself, you don't really need to worry too much about this. But if you do have the time, I would suggest looking into the differences. And maybe for a team, you might decide rebasing is a better workflow for you, or squash and merge is a better workflow. So I'm going to click merge. In this case, I'm going to select a different email to merge with, and I'm going to click confirm merge. And boom, it's been merged. I'm even going to go ahead and delete the branch. And I can go back to the code, back in main, boom, my demo.py is there, right? I want to pull those changes now. So I can go git switch to main branch, and then on the main branch, I'm going to pull the changes. And boom, it's pulled those changes. Had I not pulled those changes and I made my own changes on there, and then I would have had that conflict, it would have told me to pull first before I could then push. That is in a nutshell how you do your branches. All right, so next is your git ignore. So for example, I have some API token, super secret API token. I don't want to commit it directly into my code, so I'm going to create an environment file, right? So I'm going to go vim.env, say .env.local, boom. And here I'm going to do API token equals some random token, right? I don't want to commit this. I don't want to even accidentally commit this, right? So the best way of doing this is have this file, call it a git ignore. This is a special file that Git will recognize. And another nice thing about this git ignore is you don't just need one git ignore. You can actually have multiple in subdirectories if you want to, right? But for a simple use case, one at the root level is usually just fine. And a lot of times you won't handcraft these yourself. You can go to sites like gitignore.io, and you can tell it kind of the technologies you're using, and it'll generate kind of a standard git ignore based on that, right? In this case, I'm just going to create mine myself. I want every .env file with whatever it's expanded by. I want those committed, right? I mean, I want those ignored no matter what. So now if I do a git status, you'll see only the git ignore is going to be tracked, but that .env file is no longer going to be tracked, right? Now I'm going to show you a slightly different problem. Okay, this is great, but what if I want to have an exception, right? Let's say I want to have a .env.example. I want to track this one. let's do API token equals insert token here. All right, and I do get status. You'll see that one's not even going to be tracked, right? If I even try to add it, right, it's not going to be tracked. I can even do, so if I do a get add, and do get status again, Butterfingers, it's still only the get ignore, right? So what I can do is I can give it an exception. So the exception is simply you just do an exclamation mark, and then I can do what I actually want the exception to be. So now if I do get status, you'll see that now it shows an untracked. So now I can actually commit my .env example. But anything .env, whatever, that will still be ignored. So I'm going to stage these new changes. So even you'll see it's modified get ignore and then files to be committed get ignore. If I were to commit right now, all it would commit is the .get ignore with just the first line, not that second line. Because when I staged my changes, it took a mini snapshot of that time, and at that time I only had one line. I didn't have two lines. I want to add these ones, so I'm just going to add a -a, capital A, and then boom, I'm going to commit it. So commit setup API token. So I'm going to call it, right? I'm going to hit commit, and I'm going to do a push. And now if I go into GitHub, we'll see that when I refresh, I have a .get, I have a .env.example, but I have no .env.local. That only exists now on my machine, right? Somebody else, they would have to set the .env.local on their machine. All right, so .get ignore. Let's see what else. Let's see. Get pulled. Did merge. I did so get ignore. So there's like two more kind of special files, but they aren't quite special for Git, but more so special in GitHub and just kind of in software repositories in general. And so those are a README file and a license file. Now, for the license file, essentially it's just the license you want for your software, right? So usually if you want to make it like an MIT license or an GPL license or even some custom license. If you have a custom license, then basically just create a file called uppercase license and start typing away. But if you want kind of these pre-made ones, GitHub has actually a nice feature. So I go into add file, create new file, and then I go into name my file and I do uppercase license. You see this little button appear for me. Choose a license template. So I can click that, hit OK, and boom, now I can choose from a bunch of pre-made licenses what I want. In this case, I want GPL3, for example. I'm going to click review and submit. Boom. It's there, and now I'm going to commit my changes, right? Okay, commit changes. I'm going to choose to, just call it create license. That's fine enough for now. Email. I can choose to even put it directly on the main branch, or maybe I want to put it on the new branch and maybe put a pull request, right? Maybe I haven't fully decided with my team what kind of license we're going to use, and I might want to have a discussion on that. I can do that directly on GitHub. In this case, I'm the only person on here. I'm going to choose to just merge it or commit it directly. So boom, now it's there, right? Just gonna hit refresh. Boom. License, it now exists, right? Now, back to the terminal. All right, so now the README. This one doesn't have any special meaning in Git as well. But in GitHub, if you make a README file, that will be kind of the file content that it'll show when you go to the root of the project. And it's also just, it's a good area to put anything information the person needs to know immediately. So typical things you might want to include on there are things like how to contribute, although again, there's a contributing.md file you can also use, how to build the project, right? How to set up the environment, anything like that, anything you need the user to know, boom. Or special commands of your program, right? Say this is a command line program. All the commands you may want to type with it, you might want to include that README, right? So you kind of think of that as like kind of your quick and dirty documentation, right? But if you kind of start getting to more advanced stuff, you'll have kind of more advanced documentation systems. But for kind of the quick and dirty stuff, or just kind of the important information the user needs to know immediately, or even just knowing where the other documentation is, you want to add a link to that, it's all put in the README file. GitHub supports a couple different formats for the README file, but the ones I'm seeing the most used is just a markdown file. But there are other files you can do. You can just do plain .txt, for example. So I'm just going to create a quick file. So vim readme.md, and boom. And so if you don't know markdown syntax, it's pretty easy. And you can kind of learn that on your own. But let's say natHACKS git/GitHub. GitHub workshop. The purple is a little bit hard to read. I'll make it a little bit bigger, see if that helps. Hello. That's all I'm going to have here, right? So I've created this file. Again, usual workflow. I'm going to add the file. I'm going to commit the file. So I'm going to call it create readme. Again, super basic git commit messages. But yeah, once you start kind of doing more specific things, make sure your git commit message is not just modify this file, but actually say what you did, right? What does this snapshot actually entail? All right, so now I'm going to do git push, and it's going to give me an error that I've kind of been hinting at multiple times, right? So I made this change on GitHub where I've added this license, and now I've made this change locally where I'm creating a README, right? But if I actually go in my history, you see I don't have the change where I created the license. That doesn't exist. So when I try to do push, it's going to give me an error because my server is out of sync, or my local repository is out of sync, right? So it says rejected. Failed to push some refs to that. Updates were rejected because remote contains work that you do not have locally. So easiest way to fix this is just do a git pull. It's going to pull the changes. In this case, the first time it'll ask you how to specify. So in this case, I'll just do a git config pull rebase true. You can do false, which is the default one. Actually, yeah, I'll do that one because it is the default. But again, when you look into more advanced use cases, you like figure out what rebase does, which does modify the history. You can kind of decide whether that is something you want to do for your project or not. So I'm going to do another git pull. All right, so now it's kind of pulling out nano here. So it says, oh yeah, it's going to merge the branch main because there are these changes. It needs to merge them together. I'm good with those, so I'm going to do this nano, so Control X. Boom. It's made those changes. Now I have those changes pulled in, but again, if I go into the website and I hit F5, you'll see I still don't have that README because I pulled the changes and now I have the changes that the server has, but the server doesn't have the changes that I have. So I still have to push my changes. I do a git push. It'll push. If I go back into the website, hit refresh, boom, that README file now exists, and you can even see it displays it here, right? And so this is what I mean. Any quick information you want the user to have, I will put in the README because when they navigate to your repo, they can immediately see it without even having to look for the readme.file specifically. All right. That is all I have for the workshop. Again, kind of quick thing before I do kind of finish it off. If you have the time, highly recommend you look into how to make an SSH key. So if you go into your settings, and I go into my SSH and GPG keys, you'll see I have quite a bit of SSH and GPG keys. You don't need GPG keys if you're just kind of doing stuff. It is something I might also recommend looking into and maybe setting it up yourself. but the one that I would really highly recommend is your SSH keys. Reason being, if you're using the HTTPS with a personal access token, you probably realize that every time you try to push to the server, and maybe even pull if the repository is set to private, you have to type in that password each and every time. SSH makes it simpler where you don't have to, unless your SSH key in itself has a password. But it essentially means that if you do set one up without a password, you can essentially authenticate without a password all the time, which I wouldn't explicitly recommend it, but it is definitely more convenient, right, than having to type out an access token. Another advantage you can do, which I will switch to the other view, is it one, right? Yeah, there we go, one. You can have one of these, which might be hard to view. It's a hardware key. So one of these, you can set up your SSH with one of these, and what it will do is essentially it works instead of necessarily having to type a password, but again, you can even add another password on top of that to make it even more secure. One of these, all you got to do is, once it's plugged into the computer and you've obviously set up your SSH key with this in mind, you just tap it, and boom, that's your authentication, right? It's nice because there's no password. You just have to physically have it with you. That's pretty secure. So yeah, you can set up that with SSH key. Same thing with your GPG key. You can set it up with a hardware key. But again, SSH, highly, highly recommended. It makes your workflow so much easier. Even if you have the kind of slightly less secure passwordless, keyless, whatever, it's still more convenient to do your HTTPS. GPG, yeah, I don't really have time for that one. But essentially, that's how you can sign your commit to kind of prove that you are the person indeed who did actually write that commit. Because you've noticed at the beginning in my Git config, I just put in my name, I put in my email. There was no real confirmation that I am who I say I am. And so what you can do is with the GPG key, you would also upload this to GitHub in advance. And then every other time you make a commit and you sign your commit with that GPG key, GitHub can then go, okay, I'm going to reference this key. Is this key actually owned by the user? Yes. Okay, I'm going to put a little Twitter verified check mark. It's going to be a green check mark. I'm going to put this little verified check mark, be like, okay, the person actually wrote this commit. Because what you can do, and I don't have the example repository here, but it is out on the internet, is that I could just put in any other email that I want, right? I could put in Linus Torvalds' email. Now when I go on GitHub and I make a commit under that email, it shows it as if Linus Torvalds made the commit, even though Linus didn't actually make the commit, right? But with the GPG key, you can then be like, oh, well, sure, it says it was him, but it's not signed by him. So therefore, I know it's not him, right? So it's kind of the thinking there. And that is pretty much it. Yeah, so SSH keys, GitHub keys, GPG keys, 100% recommend those to set up if you have the time. But that is it. Any questions? If not, I will. Actually, I'll let Cameron end the stream when he decides that's good. But yeah, that's it.